Okay, so in this one, we're going to use Norton's theorem. We have solved this question using Thevenin's theorem. So if you haven't watched that video, you can just go and check it. It's the first video in the description. Okay, so Norton is just similar to Thevenin, but there's a difference. Both Norton are going to be dealing with currents. So first of all, what we're going to do, first of all, I'm going to short circuit this load resistor, which is 8 ohms. So let me draw it right here. And I'm going to short circuit the load resistor right here. Okay, so what we're going to have here, going to have the Norton current. So here is 10, here is 10, and here is 20, and here is 10 voltage. Okay, so what we're going to do first, we need to find IN, right? So what I'm going to do, I'm going to calculate the current of the main branch. So I'm going to start from here. What's going to be the resistance? So if I have my current, so these are ohms, and this one is also 40 ohms, this one are ohms. Okay, so let's say I have a current, it's going to pass through here. So I'm going to have 10 for the total resistance. And remember, this is not the equivalence resistance, it's just the resistance of the main branch. So the current is going to split here. Let me say if I say this I, I'm going to have I2 here, and I'm going to have I3 here. So the current is going to split, and this current is going to be different with this current. But if I add these two currents together, I'm going to find this current. So that means this one will be in series with these two resistors, but these two resistors are in parallel. So it's going to be 40, which is in parallel with the 20. So it's going to be 10, and if two resistors are in parallel, it's going to be the sum of the resistance, or the total resistance, will be product over sum. So it's going to be 40 times 20 divided by 60. And the answer is going to be 70 over 3 ohms. So I'm going to leave it in fraction, as a fraction. I'll simplify later. Okay, and now that I have the resistance of the main branch, I'm going to find the current. So the current, let me just call it I. Let me just put I bar. It's going to be voltage times resistance. We know that V equals to IR. So that means if we make I side of the formula, it's going to be V over R. And voltage is 10. And what about the current, the resistance? It's 70 over 3. Okay, so 70 over 3, that is going to give us, that's going to give us 3 over 7 amps. Okay, so 3 over 7 amps. Let me draw another circuit right here, show you. So we have 10 here, the voltage source, and we have this resistor, we have this resistor, and we have this resistor, and here we have the Norton current. Okay, so it's 10 ohms here, and we said it's 40 ohms here, and it's 20 ohms here. So the current that we have calculated is current right here. This is where I bar is. But what we need to find the Norton current, we need the current that's going to pass through the 20 ohm resistor, but it's going to be the same here. So we know this current is going to split here. We're going to have I bar here. We're going to have I bar. You can just say I1, I2, I3. So to find the current which is going to pass through the 20 ohm resistor, we're going to use the current divider. And of course, this resistor is high resistance, so more current is going to pass through the 20 ohm resistor. So that means to find IN, we're going to say the total current, which is I bar, times, it's going to be 40 over 40 plus 60. Okay, so it's going to be, we have 3 over 7 times 40 plus 60. Okay, actually it's 20. It's going to be 40 plus 20. It's 20 here. So it's going to be 60. Okay, so it's going to be 2 over 3. And we're going to have 2 over 7 amps. That's going to be IN. Now let's find the equivalence resistance. Okay, so this one is the same as Thevenin resistance. So now we're starting from this side. I'm going to use this. Okay, so I'm going to remove this circuit to make it clear and understandable, and redraw the circuit. So we have 10 right here. Okay, let me just cut these two terminals right here. I want to call this RN. So this one is 10 ohms, this one is 40 ohms, and this one is 20 ohms. Okay, so don't make a mistake. Many people may use this resistance, but this was the resistance of the main branch. So this one I want to find the total equivalent resistance. So like what we did in Thevenin's. So if you haven't watched the video, what we're going to do, we're going to start from this side. We're going to have our current. We're going to have this resistor. It's going to be 20. The resistance 20 ohms right here. But let's say if we have our current, then just call it I. It's going to split. We're going to have I1 here and we're going to have I2. The current between these two resistors is different, so that means 10 is in parallel with 40. But if we add these two currents, we're going to find the current is going to be equal to I. So that means these two resistors are in series with the 20, so it's going to be 10 which is in parallel with 40 times 20. So it's going to be 20 ohms plus, and the total resistance of resistors which are in parallel is going to be 10 times 40 product over sum divided by 50. And that is going to give us 28 ohms. Okay, so we can call this Rn. And now we're going to just draw our simple circuit, a symbol, not an equivalent circuit. So what we have going to have our current, right? We're going to have our current here, Norton's current. We're going to have our equivalent resistance right here. And we're going to draw a load resistor right here. If you're looking for other videos like this one, check in the description. I saw it main Norton Theorem's video. Okay, so I here we've calculated it and it was 2/7 amps. Okay, that was IN. And here we have 28 RN, which is 28 ohms. And we have our load resistor. What is our load resistor? Which is 30 ohms right here. And find the current that is flowing through the load resistor. The current divided. It's going to be I 2/7, the total current, times, and of course there's going to be low current compared to this one, right? So it's going to be 28 divided by the sum, which is 28 plus 30. And that is going to give us 0.1379 or 0.14 amps. Okay, so thank you for watching. Don't